Hi class. This video is going to end our discussion of chapter 6 when we talk about quadrilaterals by moving into section 6.5. In 6.5, what we're going to do is we're going to talk about trapezoids and kites. So we have two objectives in this section, and it's we want to use the property of trapezoids, and then we want to do the property of kites. All right, so a trapezoid is really just a special parallelogram. So a trapezoid is a quadrilateral with exactly one pair of parallel sides. So as you can see here, this is what a trapezoid looks like. They're saying that this side is parallel to this side. All right, the parallel sides of a trapezoid are called the bases, and the non-parallel sides are called the legs. So the two angles that share a base of a trapezoid are called the base angles, and a trapezoid has two pairs of base angles. Right, so these are the bases here, the parallel sides, and this is a base angle here and here, and this are also base angles here and here. So an isosceles trapezoid is a trapezoid with legs that are congruent, right? So A, B, C, D shown below is an isosceles trapezoid, and the angles of isosceles trapezoid also have some unique properties. But here, these are the parallel sides AB, and we're saying that side AB and side CD here are equal or congruent, and that's called an isosceles trapezoid. All right, so theorem 6.5-1, which is base angles of an isosceles trapezoid. So the theorem is this: if a trapezoid is isosceles, then each pair of base angle is congruent. So the trapezoid TRAP, TRAP, is an isosceles trapezoid with bases RA and TP. So if this, then it must be that angle T and angle P are congruent, and angle R and angle A are congruent. So the two pairs of base angles are congruent. Another one here, if a trapezoid has a pair of congruent base angles, then the trapezoid is isosceles. So if you're able to say trap here is a trapezoid and the base angle T is congruent to the base angle P, then it's isosceles, meaning that TR is congruent to AP here. Another one, this is diagonals of isosceles trapezoids. So if a trapezoid is isosceles, if and only if its diagonals are congruent. Meaning, so ABCD here is an isosceles trapezoid if and only if the diagonal AC is congruent or equal to the length of the diagonal BD. All right, so let's do some examples here. All right. Suppose that CDEF is an isosceles trapezoid, right, meaning this and this are parallel, and this side are congruent. Calculate the measure of angle D, the measure of angle E, and the measure of angle F. All right, so here's what we'll do. We know that, forgive the typo here, DE is parallel to CF, and angle D and angle C are same side interior angles. Same side interior angles, all right, when you have two parallels in a bisector here, which CD can be kind of thought of that way, they must sum up to 180 degrees. So measure of angle C plus measure of angle D is 180. Well, I know the measure of angle C is 65, so subtract it over, and the measure of angle D is 115 degrees. Well then, each pair of base angles of an isosceles trapezoid are congruent, so that means the measure of angle F is the same as C, which is 65. The measure of angle D is the same as the measure of angle E over here, which makes it 115. All right, so that's just using some basic theorems to find the measure of these interior angles. All right, another one, and this is theorem 6.5-4, and this is something called trapezoid midsegment theorem. So the midsegment of a trapezoid is the segment that joins the midpoints of the legs. So the midsegment has two unique properties. So if a quadrilateral is a trapezoid, then this midsegment is parallel, right here, MN, to both the bases RA and TP, right here. So MN is parallel to TP and RA, and the length of the midsegment is half the sum of the length of the bases. So it has to be that the length of MN is equal to 1/2 the length of TP plus the length of RA. All right, so some problems here. What our segment QR is the mid segment, So it's telling me here, all right, of trapezoid LMNP. So what is the value of x here? All right, so I know here that I have 8. That's the length of this one. The length of the midsection, or the midsegment, is x plus 2. And the top one here is 4x minus 10. Well, using the formula for the length of the midsegment, QR is equal to 1/2 the length of LN plus PN. Well, plugging in the algebraic expressions, I get this. All right, so the midsegment is x plus 2, LM is 4x minus 10, and PN here is 8. So now we just have to clean up this algebra. So I'm going to combine like terms in here. All right, minus 10 plus 8 gets me -2. I'm going to distribute the 1/2 next. When I do, I get 1/2 times 4x gets me 2x, and 1/2 of 2 is 1. Subtract the 1 over the 1x, and then add the 1 over here to get 3. And that's the value of x here. It's going to be 3. All right, now let's move on to kites. So a kite is a quadrilateral with 2 pairs of consecutive sides congruent and no opposite sides congruent. So like here and here, these opposite sides are not congruent, but the consecutive side here is congruent, and here the consecutive sides here are congruent. All right, so the angles, sides, and diagonals of a kite have certain properties, just like we saw with trapezoids. So a couple theorems. Theorem 6.5-5, this is diagonals of a kite. All right, if a quadrilateral is a kite, then its diagonals are perpendicular. So meaning if ABCD is a kite, and I draw this diagonal and this diagonal here, well, the diagonal AC and the diagonal BD, all right, when they cross, they form a 90-degree angle, and they're perpendicular. Next one, opposite angles of a kite. So if a quadrilateral is a kite, then exactly one pair of opposite angles, not all of them, just one pair of opposite angles is congruent. So if ABCD is a kite, then this angle here, angle B, will be congruent here to angle D, but not angles A and C. They are not congruent. Just B and D are congruent. All right, let's do an example. So I'm telling you that quadrilateral DEFG, the outside there, is a kite. I want to know what the measure of angle 1, the measure of angle 2, and the measure of angle 3 are. All right, well, solution first is if it's a kite, measure of angle 1 has to be 90 degrees because the diagonals are perpendicular to each other. Well, next, then what you see here is I have some triangle here. So the measure of angle 1 plus the measure of angle 2 plus 52 degrees here has to be 180. So we can solve, because we know measure of angle 1 is 90 degrees. We can solve for the measure of angle 2. Combine like terms here, subtract this over. Measure of angle 2 is 38 degrees. And then finally, what we can see here is that we can say that triangle DEF is the same as triangle DGF. All right, by side, 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 it has to be that way. All right, since corresponding parts of congruent triangles are congruent, well, and also this is diagonal. This angle here has to be the same as this angle here, so the measure of angle 3 has to also be 52 degrees. So we were able to just use some properties of these kites to find all the different measures there.